Okay, so for example, looking at the teaching technique data, can we fill in this table given just the information here? It's not a particularly important life skill knowing how to do that, but it's a good way of assessing whether we understand how the different terms in this table are calculated. Now remember, they're called slightly different things here. We got groups instead of treatment, but apart from that, it all looks pretty much the same as before. Remember I said total is equal to groups plus error, treatment plus error. So this term here is equal to that one minus that one. So it's equal to SS total minus SS error. We just do this, we do this one here. So how's this going to work out for us? I reckon it's about 712.89. Degrees of freedom, what happens here? Well, degrees of freedom, we could also use the same approach and say the group's degrees of freedom is equal to total degrees of freedom minus error, except they've both been left out here. We're going to have to use some information from the design. You can work out all of these numbers from the design. Remember in our case, the total sample size is 23 and the number of treatments is 4. The group's degrees of freedom, so the degrees of freedom for treatment, is another way to say that, is equal to k minus 1, which is 4 minus 1, this is 3. And the total degrees of freedom, that's equal to n minus 1. N's 23, so that's 22. And just as a check to make sure we got it right, what's this plus that? It's 22, so we're all good. Mean squared error, any mean square is equal to the sums of squares divided by degrees of freedom, which is 1196.33 over 19, which is about 62.95. The F ratio is equal to the mean square for treatment over the mean squared for error. The groups, the treatment one is on top. And we want to see if this is unusually large. We want to know if it's unusually large because larger values of between group variation argue that there's a difference between the means. And this is the thing that's talking about between group variation. Is a between group variation large compared to within group? We get a value of 3.77, give or take. And so what's the tail probability? What's the chance of getting bigger than this? Is it unusually large to get a estimate of the variance between groups that's 3.77 times larger than the estimate within groups? So we want to know what the chance is of getting bigger than 3.77, where F comes from a distribution with 3,19 degrees of freedom. The degrees of freedom for treatment first, and then the degrees of freedom for error afterwards. So that's going to be our p-value is about 0.028. So that's the answer to question 1. Fill in the missing values. Question 2. Estimate the error variance. So we have 2 ways to estimate the error variance. There's the mean squared. This one only estimates the error variance under the null hypothesis that the means are equal, and it only estimates it from k treatment means. It's got 3 degrees of freedom. It's not as much information in it. So if you're going to pick a way to estimate the error variance, this is your best one because it's using more information, but most importantly, because it's not making any assumptions about whether the means are equal or not. This is a good estimate of the error variance, irrespective of whether or not the null hypothesis is true. If you're asked to estimate the error variance, the pooled variance, this is a pooled estimate of the variance. We go with our estimate of the variance is always mean squared for error, which ends up being about 62.95. So test the hypothesis at the 0.05 level that there is evidence of a difference in mean achievement across the 4 teaching techniques. So how do we do this? First step, hypotheses. Our null hypothesis is that mu1 equals mu2 equals mu3 equals mu4. Our alternative hypothesis is that not all means are equal. Maybe some of them are equal, but some of them aren't. Or maybe they're all different, I don't know. But the point is that that statement there is untrue, is our alternative hypothesis. What test statistic will we use? Let's use an F statistic. I'm using lowercase now. Lowercase is what you usually use when you're talking about an observed value of something. If the null hypothesis is true, this thing comes from an f k minus 1, comma, n minus k distribution. K minus 1 is 3, n minus k is 19. P-value. And yeah, this, what did this end up equaling? About 3.7. P-value. We calculate a p-value by saying what's the chance of getting bigger than 3.77, where f comes from a distribution with 3, 19 degrees of freedom, and that ended up being about 0.028. What's our conclusion? We can always phrase a conclusion in terms of how much evidence there is against the null. If you're testing at the 0.05 level, you could just say yes or no. Yes, there is evidence. No, there's not at the 0.05 level. I prefer to talk about how much evidence there is anyway. And it's always worth thinking about what it means in terms of the original question. How much evidence is there that teaching technique affects mean grade, mean performance, mean achievement? I'd say there is some evidence it's significant at the 0.05 level. There is some evidence of an effective teaching technique on mean achievement. I'm not really 100% solid on this one because, how often would you get a test statistic this small one time in 30-ish? It's kind of like getting 5 heads in a row, tossing a coin. If someone gets 5 heads in a row, you think, oh, geez, that was a bit lucky, or maybe there's something funny going on. But you're not that confident. It's not like they got 10 heads in a row or something like that. So there's some evidence there. Against our data is unusual enough to say that there's some evidence against this hypothesis because our data aren't particularly consistent with that hypothesis. The variation between groups is much larger, almost 4 times larger than within groups, which you would not expect to happen by chance. Doesn't ever happen very often by chance. So we conclude that maybe the means weren't equal. Maybe this isn't estimating sigma squared. Maybe there's some between mean variation in there as well.